work done. Today we'll do work done in lifting and lowering of an object. Fine. So this is the part of work and energy, kinetic energy you can say. Now the thing is, what is written here is a lifting, one is lowering. So this is lifting. First we'll go for the lifting part. When an object, right, this is an object, so when we are lifting, first when we are lifting, so that is an imaginary line. So when you are lifting, so you're lifting this is like the displacement. So the displacement, this is the displacement. So this is the part, and like this is the part. This is the lower part and this is the upper part. Okay. So if this is the distance, we are lifting at this distance. The scenario, what will be the scenario? The scenario will be, obviously when we are lifting, the power, this will a positive. The work will be the positive part. So the force, this acceleration is the positive. Obviously we are going against this and we are overcoming the g part. So if you take the fg, so this will be negative. So work done in lifting, this is the lifting. So when we are lifting, so this is the scenario. So this fg will be the negative, and this fa, this acceleration of this object, this is, let it be object m, this will be the positive. Now the kinetic energy, this kinetic energy, let it be k, again as usual. So what will be kf? Obviously final, this kf, what will be? This kf will be this kg. So this kf, the bit kg, say cannot kg, initial, final, this is initial. So if this is the final and this is the initial, so this will be, as this is the negative part, the initial, the kf, what will be the work force wa, and the negative of the negative wg will be wa plus wg. So this we got. So this is the, in the cases of lifting of the object. Always keep in mind when this is the object going upwards against the gravitation, the object going against the gravitation. So these are the very vital part when you do numericals, when you do practical experiences in your daily life, or if you go for a project, always keep in mind. So this is the positive, as because of overcoming the gravitational force automatically comes like this, and this lower part will be negative. Again, now we are going for this, again just going for this, we are doing here, let this is imaginary line, we are drawing this. This is the displacement, lowering, this one we are doing right now, lowering, this is the displacement, and this is the object, this is m, let it be. So here, but right now this is coming down, automatically what will the scenario from this, what you get, this fa will be what, this fa will be negative, and this fg will be what, positive. So this will be negative and this will be positive, as because of the object is going downwards. Now the scenario will be what, these are the combination, this is the downtrodden. The whole formula is formulating here, keeping in mind. This is similar like this way. No. Wait. Rubbing this. Okay. Now we'll do the weight. So we have to wait. As the body's weight, I'm just rubbing it with the water brush. So I have to wait for a few time. So what we did so far, we did work, we did kinetic energy. The difference between kinetic energy gives you the definition of work also. We have done this result right now. Object displacement through the positive way against the gravitation. Along with the gravitation, what we get? The difference or the addition of the kinetic force and the negative of kinetic force. So it was the addition we got in the definition of forces from the kinetic energy. Now we'll do the same thing. Along with the spring. The object along with the spring. Always keep it in mind. So now it will be like this way in the horizontal. We'll do right now in the horizontal. Okay, as it is in the right now in the syllabus. Now we'll do work done by a spring force. Now work done, let it be a plane. Let it be a plane. And the block is here. This is mass m. Now this is axis 0. Let it be this point. From here, right now, it is in this scenario. From here, it is attached, a spring is attached with the mass rock. Now, two cases will be here. First case will be what? The first case will be like this. First case will be, we can stretch it up to here. We can stretch it up to here, and another case will be what? We can stretch up to here. So these are the two scenarios. If it is a steel, we stretched it and we compressed it. So these are the scenario. From here, these are the, let it be standard point. So from here, it traveled a distance here, stretched to a distance here, and it is in the rest. So scenario will be what? Just cases. Case 1. We'll do the case 1. Case 1. What will be the case 1? The case 1 will be Fx. Here, no forces are working. As this is x-axis, this is like the force Fx will be 0. No force working along with the x-axis. So all these forces will be Fx. Now, the scenario will be this, but the x is the positive case. Fx is equal to 0. X is here previously when we did problem with the lifting and lowering. So there we did what? This positive and the negative also. Now here Fx, no force actually working here. This is the x. X is the distance. So what will the x? What will be the x? X is what? Positive. Okay, x is positive. This is the same. Now x is positive. Here Fx as along with this. Fx positive, and this here, this Fx is also positive. The forces along with this. Now here this tranches to this. That the distance is x here. So this is d. So this will be the positive case. Now this is, if this is the d, it crunches. So Fx will be what? If Fx, so Fx is equal to here negative. So these are the scenario. We are working along with the same. Fx negative. Sorry, this is negative. This is positive right now. Now, from these three cases, I did a little bit of wrong. This is positive, it was, so it will be negative, fx will be, and this will be the, when it compresses, it will be positive. Keep it in mind. When it's stressed, the fx is negative. When it's compressed, fx will be positive. Sorry for my wrong mistake. Now, from this three scenario, from this the rest, stressed, compressed, rest, stressed, compressed. From this three scenario, what we got? We got, obviously, from everywhere a force definition is getting, and we are getting now there. If the distance, we get the F, force of the spring. This force of the spring, what will be the distance? The kinetic energy K equal to, and what this K? What is K? The spring constant. This is spring constant. So these are the things. From here, what we got? From here, what we got? This Fx will be Kx. So this is will be Hooke's law. This will be Hooke's law. This is the, so these are the whole thing we did. Keep it always in mind to get. So this is the spring constant, what we got. So all keep it in mind. Always keep it in mind when it's stressed, it is Fx, it will be the force is the negative, and then the compressed, Fx will be the positive. So that's all for the day. Thank you very much. Keep signing in and do the subscription and give likes and share it to your friends, as many as you possible. Thank you very much.